This is Darren Pulsifer, and welcome to Rise of the Stack Developer, where the convergence of DevOps, security, and cloud-native technologies are changing the way products are developed. Today on Rise of the Stack Developer, we're going to talk about the history of application development and how it's changed over the last 30 years. So let's first start with old school application development. You typically go out and you say, I've got an application, I need to go buy hardware to run that application. This still happens today, believe it or not. A lot of people still go down this route. And what we find is it's really easy, right? I've got an application. I think I know how much resources it needs, both in compute and storage, and then I'm going to hook it up to a network. Traditionally, in large organizations, there tend to be a lot of documentation with this, whether it's a systems engineering architecture, whatever it is. You end up writing a bunch of documentation to justify why you're writing this app. It tends to lead to really long development times and really no real use of technology. I have purpose-built this server for this specific thing, for this specific application, and that's how it goes. It could be a COBOL application. We've seen this several times. I built a hardware device for my COBOL application that's going to calculate HR payroll, for example. Some of those systems still exist today, and they've been around for 40, 50 years in some cases. What we also find is a problem with the old school technique is that it can be very hard to integrate new technology into it or new applications. Because everything is self-contained, it can cause you some problems when you want to go back and start integrating with other things. So I guess it's been almost close to 15 years now, maybe even closer to 20 years now, we had hardware virtualization, thanks to the likes of VMware and others in that same boat, like KVM and hypervisors like Hyper-V. We now have the concept of virtualization. Now, virtualization gave us virtual machines. It also gave us, just recently over the last 5 or 6 years, virtual storage and also the latecomer to the whole game, but taking off like wildfire is network virtualization functions. So now we've added in this hardware virtualization layer, which makes it much easier now for me to provision hardware resources for my applications. And they're virtualized now. So now I can use the same piece of hardware to run multiple applications. And I've kind of abstracted away the need to know every little detail about the hardware for my application. This is really good. This gives me common hardware that I can reuse over and over again. It's going to decrease my cost in my IT organization, both on CapEx and OpEx. So this is all good news. One thing that pops up when we start doing virtualization is security concerns, because now I've got an application that is running with other applications on the same hardware. Where in old school methodology, where I build hardware for a specific application, I can really lock things down pretty tight. So now I've got this concern with increased security concerns, right? Because now I've got multiple applications running on the same hardware. So you can still increase security, but now it's an extra effort that you have to do. Another big problem that we have with virtualization is the concept of noisy neighbor. Now, a noisy neighbor is really easy to understand when you can consider that there are multiple applications running on the same machine. And there are consequences of that happening. It can be that one application is really, hammering the network, which could impede your use of the network for your application. Or it could be hammering the I/O bus or memory or lots of other things. So you have to be somewhat cognizant of that. most of your modern virtualization hypervisors have in some protections here, but not completely. Right. So hardware virtualization really took off about 20 years ago. Really great. Things moved very quickly, and we also saw an increase in the number of applications that were being developed, which is really good, right? Because now I can do more with my data than I've ever done before. Then steps in cloud technology. Now, cloud technology, really what they did with cloud technology was they let you rent out their infrastructure, and it started primarily with Amazon. There were some other companies before that. A great example was Sun Technologies. Sun Grid Engine had a public cloud offering. Most of you may not know that. Their business model wasn't quite as, what's the right word, monetizable as Amazon's, because they charge per CPU time, where Amazon is charging wall clock time, which means Amazon had the ability to over-provision machines and get more money out of an individual clock cycle than Sun Grid Engine, which was only charging you for the time that you used CPU time on their machines. So cloud really took off when that business model shifted. People could then go and buy hardware, both compute, storage, and network, for a certain amount of time. This was great if your company didn't want to invest in CapEx costs for those bursty type of holiday seasons, for example. And this gave you the ability to burst out into the cloud and consume all that capacity that you needed during that time. They also took care of a lot of operational things that you would normally have to do with your own infrastructure, which made it much easier to consume. So they did a great job with this, right? So it decreased your OpEx and CapEx costs, the way that they set this up. Now, it also increased some other concerns. Noisy neighbor now goes up even more, because now you have no control over some of the other applications that might be running on the public cloud that could be impeding you, right? And then you also have integration costs. Now your data is now sitting in the public cloud and possibly in the private cloud. This is where I see a lot of organizations today. What do I do? Do I do everything in the public cloud? Do I have some private, some public? And that integration cost goes up because things are very different in the two clouds, both on-prem and then in your public cloud. Now, we also saw in the last 6 years or so the increase in private cloud technology, where that ecosystem has gotten much richer. And now I can do a lot of the same things that I can do in the public cloud in my own private cloud, which is really nice. The operational side of things has become much easier. So these two technologies together are very viable options, where maybe 6 years ago, public cloud was really the way to go to cloud, and private cloud, the technology and ecosystem just wasn't there yet. But now in today's ecosystem, I would say they're on par with each other and doing pretty well. In fact, many of the public cloud offerings that are out there today are also offering private cloud or on-prem offerings of their own technology. And we're seeing the same thing with the private cloud vendors like OpenStack, Red Hat, and VMware and Nutanix are all offering offerings in the public cloud as well. We're starting to see a mesh of those two. Now, the next thing that we saw happen, and we're really in the throes of this today, is server and container technology sitting on top of these cloud offerings that are out there. People talk about serverless. Well, guess what? In reality, you still need a server to run your application or your servlets, whatever you want to call them. It just may be happening under the covers. And that's where we're at as far as app development. Now, I drop my application on several containers, and those containers then get deployed out into a private or a public cloud. what container and service technology have offered us is yet another level of abstraction. Instead of me thinking about, I need a VM, I need a volume that's mounted in a certain spot, now I've abstracted that to another level where now I just have a container that may need a certain size of VM, or maybe it doesn't, right? Maybe I don't even care about that, just run it on any old VM. So we're starting to see at the service management layer a pretty rich ecosystem just in the last 3 years. The main competitors there have been Kubernetes, which appears to have won, Docker Swarm, and Mesos as your service management layer. And there are several other new projects that are sitting on top of that to make it even easier to deal with containers, volumes, and these overlay networks. So really rich ecosystem, still a little young, but moving along quite well. The really cool thing about this is the service management layer, a lot of them are including like a multi-cloud architecture. So now I don't even care which cloud my containers are running in or my applications that make up my containers. I can even have an application that's spanning multiple clouds because I've got containers that are running both in my private cloud and my public cloud, and I've created an overlay network that connects the two together. Really cool technology. Much easier to integrate than VMs talking to each other because they've abstracted a lot of that connectivity away. What we have is increased complexity. Instead of dealing with a 3-tier architecture, now I'm dealing with tens, if not several dozen services that are running, and that increases my complexity, which makes it a little bit harder to manage. And then the big question that comes up with all this, I've abstracted everything away. Now my big question is where's my data? Is it in the private cloud? Is it in the public cloud? That service management layer, they haven't really done a great job at fixing the volume or the storage issue yet. They have some inklings of moving in the right direction. We'll have to wait and see how this all pans out over the next couple of years. Now, another thing that's happened in this is Internet of Things. And you guys have all heard about Internet of Things. It's going to increase the number of devices on the internet by like tenfold. The amount of data it's going to generate is astronomical. And we've actually increased the amount of complexity yet again. Now my data is not in a public or private cloud. My data is out there in the Internet of Things. I've got all of these devices that are generating gobs and gobs of data. And do I move all that data? Do I move it up to the private cloud? Do I move it into the public cloud? My edge is becoming smarter now. So do I start running containers on the edge? Do I start running applications on the edge? How do I manage that? This becomes much more complex than what we had before. So as you can see, Internet of Things is a great thing because I have higher visibility. I've increased the amount of data that I can work with and get better answers. But it also comes with some concerns, like security concerns. I no longer have security within the walls of my private clouds within my data center or even in the public clouds in their data centers. I now have a small mini data center sitting on a camera on a light post in a city, in a smart city, for example. This becomes pretty tricky, right? And then where is my data? How do I manage that data? How do I trust my edge devices? How do my edge devices trust where they're pushing data to or pushing results of running analytics on the edge? Lots of big questions here. How do I manage this? This area here is still really nascent, still a great opportunity for startups, great opportunity for companies to invest in. Whoever can figure out a lot of these issues right up front is going to make a lot of money and hopefully solve a lot of problems. Now, the next thing that I think we're going to see happen is something that I call data and information management. Now, you would think the chief information officer would be all over this, right? Because they are the chief information officer. But I kind of hate to say this, but I really think CIOs over the last 20 years have turned into chief infrastructure officers, not really watching out for the data, but more concerned about reliability, concerned about cost, security, and physical infrastructure, more than really looking at data. And we've seen a major trend over the last 3 or 4 years on a new chief executive called the chief data officer. Maybe that's because the CIOs, of which I was one at one time, I can tell you I wasn't concerned about data nearly as much as about infrastructure and keeping everything going. And that's maybe because the CIOs have kind of dropped the ball on that. It's hard to say. It's hard to keep everything running while also looking at the future. So this is a tough one. But the good news is we're starting to see some companies really think hard about this problem that IoT has introduced and containers have introduced, and that is the management of data across several different locations, both public and private, and now out in the fog of the IoT world. So the concept of the distributed information management layer is a concept that we see starting to bubble up. If we do it right, we will have automated data management. We will understand where data is generated. We will be able to govern that data. We will have lineage and all those sorts of things. Again, now this data distributed information management layer, or DIML, we've got to be concerned about security and how we're protecting that data. And also, we need to make sure that we are classifying profiles of data as you move into like government space or public sector. Now there's other rules and regulations around what you can do with that data and how that data needs to be managed. So if I take a look at a high-level view on how all of this fits together, I have to make sure that I have security across the whole board, from the application layer all the way down through the information management, service management, public and private clouds, Internet of Things, and down into the physical layer. Now, there's two major aspects of security. One is your security aspect that we tend to think about as far as protecting my infrastructure. So I'm doing detection, encryption of my data. I've got hardware root of trust, so I know who's running in my system is the right people running in my system. And then I have remediation once I've detected something. So that's your typical security aspect. Another really interesting aspect, and I used to just call it identity in security, but talking to a lot of customers recently, I've realized that identity is becoming even more important, especially when I've got identity that spans across multiple clouds and across IoT devices. So not only is it the identity of the person accessing data or applications, but it's the identity of your Internet of Things devices. They need identity. They need access, authorization, authentication, and I need to manage keys across these devices as well as individuals. So this becomes an interesting aspect, and it's one we're going to be watching out very carefully and hopefully influencing over the next couple years. Now, if I look at the high-level picture on how all this fits together, you can see this high-level view or architecture of what we think the data center without walls will look like, where I've got my security and identity aspects that span the full stack from application layer down to physical layer, and then I also have my security aspect doing the same thing. On the bottom of this stack, I will still have hardware. You still need silicon to run the actual things. People kind of forget that sometimes. They go, oh, containers will be the downfall of the OEMs. Oh, actually, I don't think so. Actually, I think it will increase the amount of applications that we write, which increases the consumption of that physical layer. So I think I'm very bullish on the OEMs and on silicon manufacturers because I think we're going to see a huge drive in consumption of data over the next couple decades. But in order for that to happen, we're going to have strong abstraction layers, like our software-defined infrastructure layer, which includes my public and private clouds, like my service management layer, which is my container ecosystem, like my distributed information management layer, which still needs to be built out. And then my application layer, I even see my application layers becoming even more and more abstracted away from the hardware and more talking about what we dreamt about years ago, service level agreements, quality of service, that they are passing those kinds of requirements down into the layers below, and those layers below will then serve up the appropriate hardware, network storage, compute at the right time in the right place.
Thanks for listening to Rise of the Stack Developer. If you enjoyed our podcast, go ahead and subscribe, give us 5 stars, and let other people know. If you want more information, like tutorials, videos, white papers, check out our website, riseofthestackdev.com. Until next time, go out and build a new world, one stack at a time.